I've got a deck of 60 slides. I'm going to go through them quickly. So if you have a portable device, you might want to grab a copy here, and because you might not see all the details otherwise. So, and actually I have a little clicker right here, if I can turn it on. Okay, let's talk about SQLite. I wanted to give this a brief introduction about what SQLite is, what it is not, and why you should be using it. I really didn't know what to title the talk. Dustin put it this, the database at the edge of your network, so I put that there. But I might also title the talk Misunderstood and Underutilized.
And mispronounced.
I don't care how you pronounce it, Andrew. You call it anything you want. You might also call it, why aren't you using this more? That's what this talk is about. So you might have heard of SQLite. You're familiar with SQL. There's a bazillion SQL database engines out there. And a lot of people, they come with the idea, SQLite, well, it's just a little toy version of MySQL or Postgres. How many people here are using an SQL database of some sort? Hey, show of hands. MySQL, raise your hand. Postgres, SQL Server, Oracle. What am I missing? Informix? Yeah, okay, nobody. So SQLite is not, people look at it and say, well, SQLite is just a baby version of these. That's not its purpose. It's trying to solve a very different problem. It happens to speak the same language as these other guys, but it really has a very different focus. So rather than being in competition with these others, we say that SQLite is in addition to these other guys. You use them both, and that's what this talk is really going to try and drive home. SQLite is designed for storing local data, the stuff that's nearby your application, whereas the other client-server database engines are designed to store a global repository for the entire enterprise. The other guys are the enterprise data depot. This is the big pot in the middle of the room where all of your data goes, whereas SQLite is more geared toward an application file format. I'm going to talk more about that as we move forward, but first a quick introduction about what is SQLite. These other database engines, can I walk on the floor? Can you still see me? Because I'm going to fall off the stage if I don't get off of it. The other, MySQL, Postgres, these are the big applications. They're client server. They run as a separate process, and then your application connects to them using some sort of inter-process communication, usually TCP/IP, but that's a detail. But SQLite is different. It's a library that you statically, or that you link in with your application. It runs in the same address space as the rest of your application. It writes directly to the disk, a single file on disk. Whereas if you've set up a MySQL installation, it's got some magic folder somewhere on your computer where all of your data goes. Who can tell me the name of that folder? Anybody? Didn't think so. You don't even know where the data is stored. There's really nothing wrong with that, but SQLite is taking a different view. You store your data in a specific file. SQLite doesn't have any configuration files. When you're setting up MySQL or Postgres, after you do the install, you've got to open up the configuration file and tune it and tweak it and add user permissions, whatnot. There's none of that. You've got automatic recovery if you have a crash, if you have a power loss. There's nothing you have to do to recover the database, to roll back the previous transaction. It's completely automatic. It's portable C code, cross-platform, well-defined file format. The file format is stable. Other database engines, if you upgrade from Postgres 8.6 to Postgres 8.7, you know what you have to do? You have to dump out all of your data into a portable format, install the new server, then re-import all of your data. They change file formats when you do an upgrade like that. With SQLite, the file format is fixed and stable. It's documented. We've got a document online which is sufficient for somebody else to come along and write a competing implementation if they want to. So, I mentioned that SQLite is in the public domain. There's no licensing involved, so you're free to use it for anything you want. There's the website there. I wrote SQLite about 15 years ago. I was having a problem. I was doing a problem, kind of one of these things that Skocum does, where it's a contract programming thing. And I had to read a bunch of data out of an Informix database. And sometimes that Informix database, when they would reboot the machine, the Informix database server would not come up. And so they'd launch my application, and my application would print a dialog box that looked like that, because that's what dialog boxes looked like 15 years ago. And so it was my program that was printing up that dialog box. It couldn't connect to the database engine because it didn't come up. And so even though I had absolutely nothing to do with the database, I got the support call because it was my application that painted the dialog box. And so that was annoying, and I'm thinking, it was read-only. I don't have any of these transactional things. All I just need to do is read data out of this thing. Why can't I just read it out of a disk file? So I wrote this little program, SQLite, which did just that. It stored all the data in a disk file, and then I could read it in, and I could boot up. And then if the machine were healthy enough to actually, allow the user to double-click on the icon for my application, then it was going to be healthy enough to read the database. And that saved me a lot of early morning support calls. So that was its origin. But and I put it out there, and I've written a lot of open source software before, and I put it on my website, and it would get 5 to 10 downloads per year. And I figured this was just another one of those, and I put it out there, but it really got popular really fast. And before long, companies were contacting me and saying, hey, can you support this for us? And I thought, sure, absolutely I can. Let me get back with you. And then it's like, how much do I charge for that? I mean, how does this work? And I didn't realize you could make money off of open source. I thought I was just putting it out there. So, but it's been picked up now, and it's in just about everything, all the devices you own. It's in your smartphone. It's in every smartphone. It's in your tablet. It's in your game console. It's in your camera. It's probably in this camera right here that we're looking at. It's in, it's in the avionics of the Airbus A350. It's in all kinds of software. It's in Dropbox, all the big web browsers, not IE. It's, but all the others. But it might be in the next one because Edge? Maybe.
The name for the new one.
Oh, is that the new one? It could be. Because Microsoft has now announced, as of 2 weeks ago, that SQLite is now built into Windows 10. It's a core component used by the operating system. Windows 10 will not boot without SQLite. They contacted us, and we had to produce a special version of the DLL that used standard call rather than CDECL, just for them. Okay, so Skype, QuickBooks, iTunes, Wikipedia. There's lots of things out there using this. It's really amazing. So it's found in every phone, every iPhone, every Android phone, every Mac, every Firefox, Chrome, and Safari browser, all these other software. It's built into Python and PHP. Apparently it's also built into Ruby. Well, Ruby on Rails anyway. Most TV sets have it. It's in your, if you got a newer car, it's in the, all the new cars have the multimedia entertainment center. That's pretty much all powered by SQLite and millions of other applications. I did a question online the other day. I was talking with the community. What is the most deployed software library in the world? And is there anything that has more deployments out there right now than SQLite? And we came up maybe ZLib, the compression library. I kind of think that's number one, but other people are saying, well, no, that's not number one, because with ZLib, there's a single shared library that's on the machine, and everybody uses that one shared library. With SQLite, everybody statically links their own copy. So the machine has multiple copies of SQLite, but only one copy of ZLib. I don't know if that's a good argument or not, but it's possible that SQLite is the single most deployed software in the world today. If certainly not, it's within the top 5. So here's a fun chart. Here's this is Apple's stock price from when they went public through about 2012, and this is before their split, their 7-to-1 split. And I cut it off here because now this would go on up to like 900 or something, split adjusted. But it's really interesting to look at this because it starts down here, and it was really kind of a penny stock for like 20 years. There was a little, this is the tech bubble here. It was a kind of penny stock right here, and then suddenly they just sort of took off like that. You see, they were flat for a long, long time, and then suddenly they really took off. I'm just saying. I'm just saying. It's absolutely true. We've got a lot of fans. I saw a tweet I think it was Wednesday, and I thought, I'll throw this in the deck for Skocum. Here's, I don't know who Eric Busboom is. He says, I proposed to my wife in SQLite. It's that awesome. I don't know Eric. I'm sure he's a nice guy, but he might be taking this a little bit too far. Anyway, SQLite by the numbers, it's one file of C code. One file. Now, we don't actually edit that one file because it's a big file. It's 160 lines of code. We've actually got like 100 files that we edit, and then we have a make process that builds this one file. And actually, there's a lot of code in there that's machine generated as well from high-level specs that we give it. But there's one file. So if you want to import SQLite into your C application or your C++ application, you just take this one file and you drop it in with all the others and compile it, and then you've got a full-blown relational database built into your application. There's 3 developers, myself, Dan Kennedy from Brisbane, and Joe Matashkin from Seattle. We've been working on it for 15 years. 100% modified condition decision test coverage. This is an FAA standard. We follow DO 178B. They're actually on this. DO 178B is the specification you use for safety critical aviation software. Actually, now it's DO 178C, but I haven't paid the fee to get my upgrade yet. So, but they're about the same. So anyway, it's very detailed. 100% branch test coverage, or this is basically, you have to have test coverage such that every branch operation at the machine code level goes in each direction at least once. And really, you're also supposed to show that every branch instruction affects the output as well. So we've got that and more. We're just fanatical about testing, because when you're on everything, when you run the world, the least little bug causes major pain. So we have to be very, very careful that we get it right. So we have aviation grade testing. There's about 22,000 or 23,000 branch instructions at the machine code level, which gives you a measure of how big it is. 94,000 source lines of code, that exclusive of comments. If you throw in the comments, it goes up to 160,000 lines of code. So we do have a lot of comments, and they're not boilerplate comments either. They're actually real comments that tell you what the code intends to do. They're useful comments. And the idea here is that we want SQLite to last a long time. We want SQLite to be readable and understandable by programmers who are not yet born. So it's very well documented that way. Less than a megabyte compiled. Millions of applications use it. I just ran a test run the other day, and it did 177 million different tests, all of which have to pass. And that's on one platform. That's actually one of 3 test suites on a single platform. We actually do that on multiple platforms, where, various different flavors of Unix, Windows, VxWorks, OpenBSD, Mac. And we also do it on different processors. We've got a 64-bit Spark, which is big Indian. We've got a 32-bit PowerPC. We do ARM. Of course, we do Intel. We do all these things to make sure everything's working real well. And then last year alone, 2014, of course, precise numbers are difficult to know, but if you add up all the things that shipped with SQLite, we've got over 2 billion new installs last year alone. So it's kind of a popular program. Features. It's got a well-defined cross-platform file format, power-safe transactions. That means that if you're in the middle of a transaction and your machine suddenly loses power, either the transaction goes in completely or not at all. When the power comes back on, you don't have half of the stuff saved. It's either all or nothing. That's a very important property. We've got the usual triggers and foreign keys. We have full text indexes, R-tree indexes for geospatial queries. We've got advanced features like recursive common table expressions and partial indices that MySQL does not have. Does MySQL have R-trees? Does anybody know? MySQL people? Don't know. Okay. Anyway, the limits. A lot of people think, well, SQLite, it's got light in the name. Must be little bits of data. Actually, we've got very high limits. The one thing we are limited on is just we only like one writer at a time. Lots of different processes can connect to the database at once, but they have to take turns writing. Okay, one writer at a time, but unlimited number of readers. We can do joins up to 64-way, strings and blobs up to a gigabyte. And that's fine. Storing large strings and blobs in an SQLite database works fine. A lot of other database vendors tell you, oh, if you got a big blob or if you got a big string, store it in a separate file and then just store the file name in the database. SQLite is not that way. I've got a slide on that coming up. Databases can be up to 140 terabytes in size. We've never actually tested that because that's hard. And the database is a single file as well. So I don't have a computer that supports a file system that'll let you have 140 terabyte files. Okay, that's big. And you can have up to, and the same database connection can talk up to 125 database files at the same time. Each of those are 140 terabytes. Do the math. Okay, one thing, if you've done a lot of SQL before, one thing that throws people about SQLite, it's more in the flavor of JavaScript or Python. It's kind of loosey-goosey with the typing system. You can give types to the various columns, but SQLite treats them more as suggestions rather than as hard requirements. So if you give a column that's a small int and you put a massive integer in there, SQLite is perfectly cool with that, and it'll save the big integer. That's not a problem. Or you can say, I've got a varchar field for 5 characters, and it'll happily take a 1,000,000 character string and put it there and save all 1,000,000 characters. Okay? We don't have a date type field. A date type, you can store your dates as either strings or Julian day numbers or Unix timestamps. And our date time functions know how to interpret all 3 of those. And we don't have a Boolean type, just use an integer. Integer 1 is true, integer 0 is false, just like in C. Actually, any non-zero is true. Okay, here's the thing I was talking about before. If you can see this, it's actually faster to read content out of a SQLite database than it is to read it directly off the disk. Adobe discovered this. It surprised us, the developers. Adobe discovered this when they were doing Lightroom. Any photographers here, do you know the Lightroom product? So it uses SQLite as its file format. And they discovered this, and they were wondering, well, do we store not our raw files, what's the word that I lost the word? Thumbnails. Do we store our thumbnails as separate files and then put the file name in the database, or do we just store the thumbnail directly in the database? And so they ran the numbers, and they found that it's faster to store thumbnails directly in the database. What these numbers mean, this is the ratio of how long or how fast information is read out of the database divided by how fast it's read directly off the disk. And so you can see for smaller blobs, it's over 2 times faster to read it out of the database than it is to read off the disk. How can that be since the database is on disk? Well, when you're reading a file off a disk, you've got to first open the file. And the cost of doing that extra open operation is enough that it gives SQLite the edge. Because SQLite only has to open the database once, whereas if you're reading a bunch of things out of separate files, you have to open each file separately. So now as the blobs get bigger, it becomes faster to stream it off of disk. But for smaller blobs, put them in the database. And actually, this is not a terrible penalty. We routinely see people put multi-megabyte blobs in an SQLite database without a problem. Very simple C++ interface. There's a detail here. There's actually hundreds of these API calls, but this is the core 7 that you need to know about. Open a database connection by calling SQLite. If you open, it gives you an object, which is your connection to the database, and this is the destructor for that object. So that's 2 down. Then you want to run some SQL. You first have to prepare that SQL. You give it an SQL string, and it produces what's called a prepared statement. This is like the compiler. With any SQL database, think of every SQL statement as a miniature program. And you have to first compile that program, and then you run the program. So prepare is the compiler. And then you've maybe got some bind is like telling you what your command line arguments are to the program. And then you can run the program here, and it runs up to the first breakpoint, which is the first breakpoint is going to be when you've got data that becomes available. And so it stops at the first breakpoint, and then you call column, and it gives you the data that's in that row. And then you keep running step until you get to the end, and then you can either reset or finalize. Reset rewinds the program back to the beginning so that you can run it over again, possibly giving it new input parameters, or finalizes the destructor. And these are big classes of routines. Like there's a bazillion SQLite 3 binds for different data types, and there's a bazillion of these for different data types. 32-bit integer, 64-bit integer, real, string, blob, strings in UTF-8, UTF-16, little Indian, big Indian, native, whatever. There's a bunch of these. So that's the basic introduction. So if you are going to program, this is what you need to know. We also have in SQLite a bunch of extensions. Since it's built into your application, you're not limited to the set of SQL functions that your vendor provides. You can create your own SQL functions written in C or whatever your programming language of choice is, and then have SQLite call them as necessary. So you've got SQLite embedded in your application, you've got some other specialized functions in your application. You can set it up so that your query can call back to your application to run these functions. We also have virtual tables. A virtual table is like, it's not actually storing the table on disk, it's reaching back into your application. A virtual table is an object, and it has things like, give me the next row, whatever, and it can look at complex internal state information of your application and use that as part of a query, part of a join, say. Application-defined collating sequences. You can plug in the file system and memory allocators at runtime. There's command line tools that come with SQLite. From the website, there's the SQLite3.exe command line tool. Everybody here, wait, who programs on Windows? Who's the primary desktop? Windows. Primary desktop Windows. Primary, yeah. Primary desktop Mac. Primary desktop Linux. Okay, well, all right, so on Windows it's SQLite3.exe, on Mac and on Unix, you of course leave off the exe. This is a command line tool that allows you to access an SQLite database. So you might want to say pull your contacts information off of your iPhone, put it on your laptop, and see what information Apple is remembering about you. It might be an interesting thing to look into. This is the tool that you would use, and this is a command line tool. I won't go into the details. Basically, you just say SQLite3, the name of the database file, and then you start giving it SQL. But there's also these dot commands that you can do for things like dot tables, tell you the names of all the tables in the database. Dot schema will give you the complete schema listing for the database. You can import a CSV file into the database as a table. You can read a script and so forth. There's a bazillion of these dot commands to help you do some things. There's also a lot of third-party tools for interacting with SQLite databases. Some people really insist on having a GUI, and there's lots of those out there. This is the one we ship with it. New, we also have this tool called SQLite 3 Analyzer. If you have some big databases, what this does is it goes through and it shows you how much space is being taken up by each table. And it's a very insightful thing, because what we find is that programmers don't have a good intuitive sense of where, what part of their data structure is using the most space on disk. If you ask them, they say, which of your tables is the biggest? They'll give you one answer, and then you look, and it's really a different one. It's kind of the same way with profiling. Most people have this sense of what part of the code is going to be running slow. It turns out that part's really fast. There's some other part over here that they weren't worried about that's running slow. Same kind of thing. SQLite 3 Analyzer will show you which tables are using a lot of data, and that's very important. We also have a tool just come out called SQL Diff that takes two SQLite databases and shows you the differences between them. Dan had a lot of fun when he was developing this. He took the cookies database from Firefox, and he made a snapshot of it, and then he went to a website, and then he made another snapshot of the database and diffed them just to see what cookies were coming up in visiting various data websites. Very, very insightful. He was shocked. He was shocked. It's a very interesting thing to do. And there's some command line options there to give you summary statistics and so forth. These are fun tools to know about. Okay, and if you want to build SQLite from sources, you go to the website, you download the tarball or the zip archive, it unpacks. On Unix, you type configure and make. If you're running on Windows, nobody here's much using Windows, so I'll skip that step. But do make SQLite 3.c, it builds the source file. Do make test, it runs a lot of tests. And, well, you know how that goes. Okay, go back to some conceptual things. If you think about the way an SQL database or any database engine works, it's actually acting sort of as a filter for data. You've got your application over here, you've got data on disk, the application wants to get some data. A lot of stuff is coming off the disk, and the database engine says, well, this doesn't meet the constraints that I'm after. I'm not going to get that back to the application. It's filtering. It's looking for the information that you want, but not everything that comes off the disk is actually usable by the application. So the database engine is a filter. So now think about this. If your application is separated from your data by a network, a slow network, do you want that network here or do you want that network here? Obviously you want the network here. You want the least amount of data possible going across the network because that's the slow link. So the key to any database engine is that you want the database engine itself on the same machine with the data. Now I bring this up because in most, when MySQL, Postgres, and these sorts of things, that's exactly the way it is. The database engine sits on the same machine with the data. It's a client-server architecture, and so this is the network connection right here. You can actually put SQLite databases on a remote machine with a remote file system, but with SQLite, the database engine lives inside the application. And so what's going over the network is now the fat pipe. That will work in the sense that it gives you the correct answer, but it's not bandwidth optimal. Because if your data is off on another machine, you really ought to be thinking about it using a client-server database engine. So here's your decision matrix. So you've got a problem, and you want to know, well, okay, what database engine am I going to use to solve this problem? And you think, all right, one, is my data remote from my application? Do I have to go across a network to get to my data? If the answer to that question is yes, then you want to go with MySQL, Postgres, Oracle, SQL Server, client-server database. Okay. Do I have big data? And by big data, I mean data that's too big to fit in a single file. Okay, if the file is it won't fit in a single file, that's big. And in that case, you need to go with a client-server database engine. Do I have concurrent writers? Multiple applications that need to be writing at the same time, and they can't take turns. They really need to be doing it at the same time. If so, then you need to go with a client-server database. The client-server databases are able to deal with that because they have a server there that can coordinate the access from multiple applications coming at the same time. SQLite doesn't have that because there's no central server to coordinate things, so it doesn't do that very well. But those are the only three reasons to use a client-server database. Those are important reasons. But if none of those three things apply, then you really ought to be using SQLite instead. So I've heard a lot of people here doing Ruby on Rails, and apparently Ruby on Rails, their default is to use SQLite, at least for testing. And that makes perfect sense, because when you're testing, you don't have remote data. It's all right there on your machine. And you don't have big data because you're testing. And you don't have concurrent writers because, I mean, how fast can you issue web requests to your Ruby on Rails server? It's only, you're rate limited. So that makes perfect sense there. But then when you go to deploy, and suddenly you have thousands or millions of people hitting on your website, well, then your data might get a little bit bigger. Then you might have multiple processes running with a central disk, and then you might have multiple writes happening at the same time. In that case, you'd want to switch over to a different database engine. Okay, but anyway, here's the checklist. You've all done this checklist if you built a product involving databases, but some of you have done this wrong. This is the error that you were making. This is the decision checklist fail. Okay, the first three parts are the same. There's no remote data, no big data, no concurrent writers. Okay, I don't need to use one of those big client-server database engines. You know what? I'm just going to open a file using fopen or whatever the primitive is in your programming language of choice and write a bunch of stuff into a file. I'm going to make it. I'm going to put in JSON or XML, or I'm just going to make something up of myself because I know better than all those other people. I'm going to put it in a file, or maybe not just one file. I'm going to create a directory, and I'm going to put lots of little files in here. A pile of files database. These are all over the place. This is not the way to do it. Okay, you give up so much when you do a pile of files database. And what do you give up? Well, before I get to that, of course, you see, and really SQLite is designed for this specific purpose. And it's not competing against the client-server database engines, it's competing with EPOpen. And here's the advantages you get. When you're using SQLite, instead of opening a file and writing stuff there yourself and inventing your own format, you get power-safe atomic transactions, you get a cross-platform database file, you can move it 64-bit, 32-bit, big Indian, little Indian, it doesn't matter. UTF-8, UTF-16, it doesn't matter. It's cross-platform. You get higher performance. Remember, we can read out of a database faster than we can read off a disk. You get automatic concurrency control. If two different applications open the same file at the same time, they are not going to bump into each other. SQLite will make sure of that. And you get incremental updating if you make a change. What time is it? I'm just... I don't, 12:42. Oh, I'm way behind. I need to go faster. I'm not going to go down this rabbit trail. Incremental updating. But the most important thing about using it this way is that it uses SQL. SQL is the secret sauce. So many people I run into think, well, SQL is just the wire protocol. It's this goofy language we have to use so that we can talk to our database engines. It's really old. It's like written in the 80s. Oh, it's older than I am. You know, this sort of thing. And it's not, but SQL is really, really cool. It's very, very powerful. There are two unstoppable ideas behind SQL. Two unstoppable ideas. And this is really key. The first one is it gives you very powerful data abstraction. And let's talk about that a little bit more. Here's who has read The Mythical Man Month by Fred Brooks? Raise your hand. Yes. Yes. In the mythical, 40 years old, 40 years ago he wrote this. It is still topical today. It's the best-selling computer science text of all time. Still topical. He says, representation is the essence of computer programming. Show me your flowcharts and conceal your tables, and I shall continue to be mystified. Show me your tables, and I usually won't need your flowcharts. They'll be obvious. Isn't that amazing? He's talking about flowcharts. You know, when he wrote this back in the early 70s, a flowchart was state-of-the-art in program construction. It was the cat's meow. Everything was, that was top line. Now I guess the state-of-the-art is, I don't know, object-oriented is kind of a little stale now. What's the trendy thing now? But you know, 40 years from now, 40 years from now, whatever you think is the new and trendy solution to all your problems, 40 years from now, people are going to think about, oh, back there, yeah, they were using object-oriented programming. Can you believe how primitive they were? I guarantee that's going to happen. But you know, his insight is still key. By having the schema, by defining a schema, you're really defining what your data looks like. And once you have a schema in place, writing the code becomes really simple. Now, Rob Pike said something very similar. Really the same thing. Data dominates. If you've chosen the right data structures and organize things well, algorithms will almost always be self-evident. Data structures, not algorithms, are central to programming. Same idea, represented in different words. Choose your data structure carefully. Here is Linus Torvalds. He says, bad programmers worry about code, good programmers worry about data structures and their relationships. And he's absolutely right. I'm going to pick on him. He said this on the Git mailing list of all places. And irony of ironies, we wish that he would follow his own advice. Because here are some things that the Git data structure does not do. With y'all, who Git users, raise your hand. Git users, everybody uses Git pretty much, yeah. With Git, if you know a particular check-in, there's no way to find the descendants of that check-in. At least no way that I've ever found. That's a showstopper for me. I can't live with that. I need to be able to go back and find what happened next. And Git doesn't show that. It doesn't show the check-ins over a particular period of time. All the time we're out there looking, we find some bug, and we're trying to understand why this bug went in or why some change happened, or what was going on in that area. What were we doing in other branches at the same time? What were we thinking back then a couple years ago? Git doesn't give you that capability. On and on. Shortage of time, I'll skip over the rest of these. But the reason for this, if you think about it, this is the kind of the underlying Git data structure. These are the commit objects. Now, if you use Git, apparently all the Git tutorials start with a detailed description of the underlying data structures and then move upwards to the user interface, which tells you a little bit of something about Git. But this is the commit objects. So this is the first commit right here, and then there was a couple of other check-ins onto that, and this it branched right here. So each one of the commits points to its parent, and then so there's some more check-ins in here. In B, we did a merge. So this branch merged into this branch, and so B points to both of its parents. So you've got these pointers backwards. But what this means is that if I have this check-in right here at C, I can point backwards in time and find out what its ancestors are, but I don't have any way of moving forward. And you can't go back and add a pointer going the other way to the data structure, because if you added something to the commit record, that would change its hash and change its identifier. You can't do that. Okay, there's a simple solution to this problem. And that's to create a side table that keeps track of this stuff. This is an auxiliary table. All of this stays the same. It's just every time you add a new commit object, you also make an entry over here in this lineage table. And it's got the parent, the child, and the rank. I'll explain the rank in just a second. So, for example, we've got an entry here that says the parent is B and the child is A. Right there, is A. And we've got an entry that says the parent is C and the child is B. Right there. And it's got a rank of, and here's the parent is D and the child is B, and its rank is 1. So the rank is showing you 0 if it's the primary parent, it's 1 if it's a secondary, 2 if it's a tertiary, and so forth. And so this little bit of data here exactly corresponds to that. And this is still your primary data. This is just sort of a little auxiliary data. And it can be reconstructed anytime you want. So anytime you need to reconstruct this, you can, and it can be keeping up to date. Every time you just accept a new object, you just make a new entry in the table. Well, given this, now you can go back and you can do queries that will give you the lineage in both directions. You can go forwards in time and backwards in time. And this completely solves the Git problem of being unable to find your descendants. Completely solves it. Here's an example of, this is example code. I won't walk you through the details. This is a procedure for finding all of the ancestors of a check-in using a data structure similar to that. The schema is a little different. The things to note here are that really this procedure consists of a single function call to something that's going to run a bunch of SQL. And this SQL is a single SQL statement. It's using a recursive common table expression to walk through that tree and find the first n-1 ancestors. You can understand this later. The key points to remember are that there's no loops in this code, there are no conditions, there's no algorithm specified. I'm leading up to the second point. There's no algorithm specified in that we're telling the database engine, this is what we want. You figure out how to get it. I'm busy trying to solve my customer's problem. You figure out how we want it, and the database engine is going to figure out the algorithm involved. There's no loops, no variables, nothing. You just say, this is the data I want, give it to me. And then the database engine is going to figure that out for you. This came up, looks like Tuesday. I had this problem, I had the slide deck, and said, oh, you know, this is a good example of where this came up. We had the need Tuesday to find all of the check-ins which added a new file. So there was a merge check-ins that added a new file. So we had the main line, and we were merging in some other branches, and sometimes you'll merge in a branch, and that new branch will bring in extra files with it. You know what I mean? So we needed to find that. How would you find that? How would you figure that out in Git? We needed to find all instances where that happened. How would you find that in Git? Well, I don't know. A bunch of Python code, I guess. I don't really know. We just did this one query, and it outputted, it gave us a bunch of hyperlinks, then we could just click on those hyperlinks and look at every instance where we had files that were added by a merge. So if you have these sorts of data structures at hand, you can do some really powerful things, which is the next point. It's a declarative language. SQL, with the whole point behind SQL is that you're asking the machine a question rather than telling the machine what to do. It's very difficult to get your mind around, but once you understand and get SQL at that level, it becomes a very, very, very powerful tool. So here's Andrew Lloyd at Berlin Buzzwords talking about at Google. He was giving a talk on Spanner, which is Google's global scale SQL database engine, which is internal proprietary. Nobody's ever seen it if you're not a Google employee. And this one talk, or a couple of talks, and one paper is all we know about it. Somehow they've used atomic clocks to get by the CAP theorem. It's all very mysterious. But whatever. He says, people realized it's incredibly powerful just to push the semantics of your query down into the storage engine and let it figure out what to do. So this is why SQL is so cool, because you're pushing off work to the database. Okay, so all that said, so what is SQLite good for? It actually works out pretty well for low-volume websites. The SQLite database, or the SQLite website, is itself run by SQLite. Of course, we eat our own dog food. We get only about 400,000 hits per day. That's not shabby though, you know. That's okay. But a lot of that static content, but a lot of it's dynamic. And when the dynamic pages are about 200 SQL statements each, and but we're running on 1/24th slice of a server, and our load average is rarely above 0.1. So there's lots of room to grow here. So for smaller websites, SQLite works great. The rule of thumb is when you need to go to multiple machines, when you're ready to go to 2 servers to run your website, if that's the point you need to switch over to a client-server database. Data analysis, SQLite is great for this. You've got a bunch of experimental data. It's in some weird format. You can pull it into an SQLite database. You can do lots of interesting queries on it. And what's really cool about this, though, is it's all in a single file, so that if you're a researcher and you've collected a lot of instrumentation data and you're doing some analysis on it for a paper, it's all in one file, and then you can email that file to a colleague as an attachment. Now, you could do the same analysis in any other SQL database, but you cannot email a MySQL database to a colleague as an attachment, at least not easily. Very popular in bioinformatics. So another big use for SQLite is as an application file format. Do people still write desktop applications anymore? Anybody here do desktop applications? One. Everybody now's doing web stuff, aren't you? Okay, well, but you know, you still have file formats. And here's some examples. Adobe Lightroom, when you save your stuff from Adobe Lightroom, it goes directly into an SQLite database. How about the MicroStation from Bentley Systems? This is the CAD/CAM system that a lot of major architectural firms and governments use for tracking things like the water system. Or like AT&T uses this, so when your technician comes out and he's got his iPad, he's got the entire AT&T network there, and you know it's really one of these CAD systems is what it is. And SQLite is the database engine that backs this. All the CAD data is stored in the database. And this has worked out really well for Bentley, because what they've done is they've gone out and acquired a bunch of other smaller companies. So you're building a big building or something, or you're designing a big building, and you develop all the big columns and stuff, and then you have to figure out, well, what happens if an earthquake comes? You've got to run some simulations to make sure that it's not going to fall over. And there's like a bazillion little companies out in the world where 3 PhDs get together in a garage and say, oh, we've got this great software for modeling high-rise structures in earthquakes. Or we've got this great software for watering, or for modeling water hammer effects on public water systems and things like this. And so Bentley would buy up these different companies, and of course their software is written in a huge variety of languages, like Fortran 4 or whatever. But see, now SQLite is their lingua franca, because they get all of these different programs can communicate easily with the database. It's completely interchangeable, and it becomes sort of their central hub for getting a lot of people to work together. I'm going to skip that for interest of time, because we're about out of time. SQLite is used a lot for data transfer. Sure enough, there are, I don't know how many are actually still deploying this, but there were at one time, it probably still are, there are cable companies. On your cable television, you got the complete program guide for the next 2 days or something, and it's in the little scrolling window. they download that whole thing as an SQLite database. It's streaming over the satellite continuously. And then it gets down on the machine, and that's really convenient for them because that little window of the next 2 hours and 3 or 4 channels that you get to see, that's an archery query against the matrix, right? So they can stream the data directly this way with an SQLite database. But the real thing that I wanted to bring to your attention here is the use of SQLite as this is its key use here as a local cache for system data. So here's a system where you've got some big data over here, and it's in a data center. It's a nice air-conditioned data center with attendants and conditioned power, and it's well connected to the rest of the world. It's a really sweet place to be a program. Yeah, you're really doing well there. And then you go up to a tower. Then out here you've got some remote thing, and it's some little piece of plastic in a box, and it's connected back to the central office via a very dodgy radio link that goes away a lot. And so, a lot of people say, well, I can just query across the radio link, but there's a lot of latency there. And then if you go in a tunnel or in a building, you might lose it. So the idea is that you pull down the parts of the data that you need into a local SQLite store, and you're querying this. And so your queries are much, much, much faster because they're local. And if you lose connectivity for a little while, you can probably still continue operating. So this is really the key use. Oh, went too far. So, John Chambers, the soon-to-be ex-CEO of Cisco, a couple months ago he had an interview, and he said that they asked him about big data, and his remark was, contrary to a lot of people's views of big data, I think the majority of data will actually be analyzed and acted upon at the edge of the network. He's talking about the data is analyzed and stored out in the phone, out in the little device, out in the thermostat, out in the radio of your car, the things out on the edge. That's where all the data is really going to be analyzed. Right now the trend is to pull all the data into the data center and analyze it there, but he's saying no, the trend is it's going to be analyzed on the edge. And that's exactly where SQLite lives. It's out there on the edge. So all of the other database engines, they are designed specifically to work in a data center. A well-attended, lovingly monitored data center which has a DBA there to handle things if things go wrong. SQLite is designed to live out on the edge, out in the jungle, out where it's rough and tumble, to take care of itself, to require no user interaction or no maintenance, to just work. That's what I mean by SQLite is the database for the edge of your network. I hope that I have some time for questions and that you have them. Questions about SQLite, questions about how it should be used, questions about why it should not be used or when it should be used. Yes, sir?
You started with the need you had. When did you realize that was the fundamental?
When did I realize that this is really the way SQLite works? Well, you think about the need that I had was very similar in that I was going, the words I used then were I need a zero administration database. I need a database engine that doesn't depend on having a DBA there to reboot the server when they power cycle the machine. And so that sort of evolved because at the time nobody thought of the concept of the Internet of Things. Okay, this was 2000. This was actually in the 90s. And so it's really the same concept, but the words have evolved over time to express it in ways that are relevant to what we're doing today. The idea is that SQLite is designed for the problem that's right here and now, localized, fast, local cache, zero administration, yes.
Was it that habit of representation that allowed you to create a file format which has stood the test of what it's become?
Yeah, I didn't really realize what a great thing SQL was at the time. I was kind of grumbling at having to access the data in the SQL format for this problem because my problem, I took over the problem from Lockheed Martin, and they'd spent millions trying to solve this, and they had all these objects that were trying to do things, and I backed up and analyzed the problem and modeled the problem as a graph problem, and realized that this problem is NP-complete. That's why you're not converging on an answer. It's an NP-hard problem, and then I was able to find some heuristics that gave them a good solution, not necessarily optimal, but a good solution very quickly. But I had to build in all sorts of monitoring to make sure it didn't. And they had lost focus of this because they were so object-oriented that they were focused on individual objects and their methods. They weren't seeing the big picture. And so that I was focused on the algorithm. I was grumbling. And so when the data that I had to pull in to solve this problem was all in a relational database, but I was sucking the entire thing into memory and building in-memory structures. And so, when the program would start up, I'd read all the data, and that was it. It was a one-time thing. It might as well have been a flat file, but But then later, as I got into this, I began to realize, hey, this SQL thing is really, really cool, and it solves a lot of problems. So it was a learning process for me. I don't expect people to understand it right away. I certainly didn't. Other questions? Yes, Dustin.
Have you ever gotten bored working on the same thing for that long of time?
Have you ever gotten bored working on the same thing for this long of time? No, these are always 1,000 exciting challenges with SQLite. Like the other day, Michael, I won't try and pronounce his last name because it's a Polish last name. What? No, it's Zalowski or something. He wrote this fuzzer that went through, and it really defined it's found lots of really bad bugs and lots of software, but he put it against SQLite, and he found a lot of problems, and that's kept us busy for the past month fixing those problems. They're all fixed now that we know of. We've been running the fuzzer continuously for weeks and weeks, and we haven't hit anything serious in a long time. And so if you download and get the latest, everything's fixed. But there's always excitement like that. There's always customers coming to us. We need this new feature. This query is too slow. It's a lot of fun. We enjoy it. It's a great job. Airbus wants us to support SQLite for the life of the A350 airframe. So that means I will be supporting SQLite until I'm in my 90s. I'm cool with that. I'm good. Other questions? Yes, sir.
So, have you ever thought about adding new data types?
Have I ever thought about adding new data types? Well,
UUID, anything like
yeah, that would require a file format change. And a big part of SQLite is that the file format is unchanging. So that the database you have today is going to be accessible 40 years from now. And so there's a little bit of wiggle room in the file format. And we have extended some things a couple of times, and we've got a little bit more space to extend, but we're not in a big hurry to use up what's left or our expandability. We want to be very, very selective about what we put in there. So we don't have plans to put in like a BJSON type like in Postgres. Now you can always store JSON as a text string, and we can add new things to access that efficiently. But you're thinking of a data type that's like parsed JSON that could be indexed, and so we don't have plans to do that right now. But it could change. Other questions? No more questions? Yeah.
I was kind of curious how you decided to separate the tables in one file.
And
separate the database tables in one file? What method did you use to keep them distinct?
Yeah, that's getting down into some low-level stuff. Well, I could bring it up there. It's hard to say. So it uses a B tree structure, and there's a single B tree that's rooted at page 1, and that's the root of the B tree. The database is built up of pages, and they're all the same size. Let's just say they're 1K. They can be different sizes depending on the database file, but in each one file they're always the same size. So put 1K. So the first 1K is the root page of the SQLite master table, and then it might have other pages as it fills up, but there's pointers to the other pages in that root page. And then that SQLite master table contains the root page of every other table as part of the schema. and come to me afterwards, and I'll show you the details.
It's over my head.
Yes. More questions? Yes, sir.
Have you ever done a big rewrite?
Have I ever done a big rewrite? We commonly rewrite major subsections of SQLite. Because we have this massive, amazing test protocol with thousands of times more test code than we have actually production code, we strip out entire subsystems and rewrite them periodically, yes. That's like serious refactoring.
Yeah.
And we can do that and get away with it because we have such intense testing. So really the SQLite product is our test scripts. That tells us what SQLite is supposed to do. And then, you know, the code that we ship, that changes massively from one release to the next. And we don't even announce it. We just change it. It works the same, it's just a little bit faster.
So are most of your testing at the functional level as opposed to unit tests?
Part of DO-178B is that you fly what you test and test what you fly.
Okay.
Also, you're only allowed to use published and documented interfaces for your testing.
Okay.
So SQLite is designed in such a way that we can actually test everything in excruciating detail using published interfaces.
Nice.
So that's hard. It's hard to get there.
Yeah.
We spend a lot of time maintaining that. But you know, when you run the world,
Yeah.
it's an infrastructure thing. When you turn on the water at your tap, you expect water to come out.
Yeah.
When you store stuff in the SQLite, you expect it just to work. That's not something that you want to have to fuss with.
Yeah. Any lessons learned from going through that process?
Tons. We could talk all day for that. Yeah. Yeah. That we don't have time for that now, but we can chat later over coffee. Okay. More questions? I'm way over time, I think. How far over am I, Andrew? Yes, sir.
You mentioned the aerospace industry a lot. Is there any other sources of inspiration for your career that you've kind of drawn on as well as SQLite?
Well, yeah. I mean, everything I've done has led up to SQLite. Yeah, certainly I didn't know about DO-178B until some aerospace companies started contacting me. And then, because you have to buy that specification, you have to pay for it. And I went and bought a copy and read it. And it takes a year or two to kind of get your mind around it because it's written in you know, that kind of weird language that aviation documents are written in. I don't know. It's you know, technically it's English, but you have to. Yeah, it's hard. If you ever read an aviation standard, have you? I don't recommend it, okay? But it took me about a year to kind of come to grips with it, and it made a huge difference. That was when Android was just kicking off. In fact, Android might not have been publicly announced, but we had been called in to help with get Android going with SQLite, and they had been publicly announced, and there were a bunch of Android phones out, and we were getting flooded with problems coming in from Android. I mean, it worked great in the lab, worked great in all the testing, and then you get out there and you give it to 200 million people and let them start clicking on their phone all day, and suddenly bugs come up. And this was a big problem for us. And so I started doing this, following this DO-178B process, and it took a good solid year to get us there. Good solid year of 12-hour days, 6 days a week. I mean, we really, really pushed, but we got it there. And you know, once we got SQLite to the point where it was at that DO-178B level A standard, we still get bugs, but you know, they're very manageable. They're infrequent, and they don't affect nearly as many people. So it's been a huge, huge thing. For something, if you're writing an application, you know, a website, a DO-178B is way overkill. Okay, it's just because it's very expensive and very time consuming. But if you're writing an infrastructure thing like SQLite, it's the only way to do it.
How long does it take to run your tests?
The longest test package we have, the one that you saw that was 177 million, takes about 8 hours on a modern workstation. We've got another test package that runs for 16. We just did a release yesterday. That was the request of Mozilla Firefox, and they requested it on Monday morning, and it took us until yesterday to get there. So we've got to run all these tests on multiple machines, and we've got a lot of manual analysis and code review to do as well. It takes 3, 4, 5 days. Well, we did it in 4 days because we didn't run into any serious problems. Assuming you don't run into problems, it takes about 4 days to do a full release test cycle. 3 guys working on it. So, all right, are we done?
Well, would you mind sticking around?
I'm happy to stick around. Is there any pizza left?
Yeah, so